going to have a look at reversible reactions today. Now, reactions are basically divided into two categories. Most of the ones we come across are irreversible. For instance, let's make something like a cake. We put all the ingredients, they go in a bowl, and we put this in a cake tin, we put it in the oven, and out comes our cake. There's no way I can take the cake and go back to make the ingredients. It just doesn't work. So it was quite interesting in around about 1850 when a scientist called Claude Louis Berthollet he sort of came up with this idea that when he had some chemicals he could do some bits and pieces with this. There's this gentleman, 1748 to 1822. Right, so around about then, what he was doing, he was looking at a certain reaction, and he was looking at sodium chloride, and he was looking at this with calcium carbonate, and he found out that this reaction would go, in fact, one way, but he could actually make it go the other way. And this was something really that he found quite interesting, that we could get a reaction that went both ways. So basically you take two chemicals, A and B, and you react them and they make some other chemicals, C and D. We start off with our reactants and we end up with our products. But he also found that if you took C and D and you did something to it, you could make A and B. So these products became the reactants, and the reactants could become the products. And so we end up with a different type of arrow, one that now signifies the reaction can go both ways. And since his discovery, there have been found numerous numbers of experiments of chemical reactions that in fact are reversible. Now, one chemical that we can see that does that you might be familiar with is one of litmus. So let's go and have a look at some litmus. Now let's just take some litmus. I've got here some litmus paper, and this is sort of a pinkish paper, and what I'm going to do with this is I'm going to have a look at this with either an alkali, sodium hydroxide, or an acid, hydrochloric acid. So let's get out a couple of small beakers and we'll have a look at this reaction. Now what I'm going to do is just take a little bit of sodium hydroxide. I needed a tiny little bit here for this experiment, and we'll take a small amount of an acid, in this case hydrochloric acid. if we put this into the alkali, I'll just hold it up here so you can see, we can see that the litmus has changed from its pink colour to a blue colour. I'll try and zoom in just a little bit here. I'll be able to see that a little bit better. Right, so alkali with this paper.
I didn't hear that. Please try that again.
I'm being supported by some unknown device. There we are. We've got blue. Now I've done that blue, but this one I've got blue. I'm going to put this into acid. And we can see that it's changed back again and it's gone pink. So it was blue, and then put it in the acid, and the blue disappears and it becomes pink. I'll put it in the alkali again. And it becomes blue again. So this reaction is going from, I'll try and put it on there, it's a little bit easier to see. So it goes from pink to blue to pink to blue, and just by depending on what solution I have it in, whether it be an acid or an alkali, this paper changes. It is a reversible reaction. Now litmus is quite a complicated substance, but it still shows this property of changing from one colour to another. Right, I'll move those out of the way, and what we'll do is we'll have a another substance that might do this sort of thing would be ammonium chloride, and usually you get an opportunity to try out a couple of these experiments so you can see what goes on. So if I move away from there and we go back here, let's look at what we just saw. We had here basically red litmus will go to blue litmus. All I have to do is change the conditions. If it is in sort of alkaline conditions, what's happening is basically the hydrogen ion is separated from this substance, the litmus, and in here we've got the hydrogen attached to this substance, the litmus, and both here are dissolved in water, aqueous, and this happens in acidic conditions. So if it's acidic, we've got it going red, and if we've got it alkaline, it's turning blue. Let's look at another substance though, an experiment that you might try in school, and this is an experiment where we use something like ammonium chloride, and what we're going to do is with this we're going to turn this into hydrochloric acid plus ammonia, and if I add heat, that's what it's going to do. But if we cool it, then the products that we've made will turn back into ammonium chloride. Ammonium chloride is a white substance, and what I'm going to do with this is I'm going to put a small amount at the bottom of the boiling tube. I'm going to put some mineral wool up here. The point of using mineral wool rather than something like cotton wool allows gases to go in and out, but cotton wool would tend to catch fire, whereas the mineral wool won't. As I supply some heat here, we're going to see really nothing happening because we're going to get two clear gases, but as it cools we should see the solid forming again. So we're going to try this at an angle, and we're just going to try heating the bottom of the tube. So let's have a go at this one and see what we can do. Now for this experiment I'm just going to move my Bunsen burner and I make sure that its hole is closed before I light it. Now I've got my boiling tube, I've got some mineral wool here, and what we've got is this substance, ammonium chloride. So let's take a little bit of ammonium chloride and put it in. Ammonium chloride is a white solid. It tends to form lumps quite easily, and I don't really want any lumps, so I'm just going to put a little bit of this bigger lump than I want. And just do that. Put the lid on, move it out of the way. So here we've got some ammonium chloride, and I'm going to put this little bung at the top, and because I'm going to heat it, I'm going to hold this with what I'm finding is a slightly better test tube holder. I tend to use one of these as a test tube holder. I find my test tube holders a little bit too springy and aren't so helpful. So I've got my substance ready to go. Let's just light the Bunsen. And let's gently warm this substance. Now we can see I think I'll just turn that off. What we've got here, the ammonium chloride here was heated. We don't seem to have anything here because it was fairly hot, and that is still radiating heat. I can feel the heat here on my hands, so I'm not going to touch. But here it's much cooler, and so the ammonium chloride has been made again, and it's sort of gone onto the test tube. Not really that easy to see this one. This is one that we do, but it's probably not the most convincing of experiments that go basically two ways, although here we've seen it do just that. A better experiment might be to have a look at the difference between these two substances. Now this is copper sulfate, and this is copper sulfate. They are one and the same chemical. The difference is that I've heated this and it's turned white and it's become anhydrous copper sulfate, and if I add some water to this I can make blue copper sulfate. So that's what we're going to have a look at now. Let's go through and have a look and see what we're going to do. So in our previous experiment we got that to work. We saw the ammonium chloride forming on the side of the test tube. So we have some sort of reversible reaction, and if I put some state signs in here we can see that that was a solid and these are gases. But I'm not really that convinced with this reaction. We use this symbol to try and show that something is actually happening here, but I'm not that convinced. I need to sort of have a better idea. So what we're going to do is we're going to take some copper sulfate and this is hydrated, which is blue, and we're going to supply here some heat to this. As we do this we make copper sulfate. This time it is anhydrous, which is sort of, I'd like to say it's white, but often people say it's more grey, plus water. And we're going to do that as one experiment. Then we're going to do a second experiment. So there is experiment number 1. And then we're going to do experiment number 2, where I'm going to take copper sulfate, which is anhydrous, which is white, and I'm going to add water to this, and what I'm going to get is copper sulfate, which is this time hydrated, which is blue. And what I will do here is we are going to put in heat, and this should give out heat. We call this one endothermic. And we call this one exothermic. End like for entrance, exo like in exit. Entrance where you go in, so you put in heat. Exit, come out, give out heat. So endothermic takes in heat, exothermic gives out heat. And what are we going to do with this experiment? Well, the first experiment then, I'm going to take a boiling tube, and into this we're going to put some copper sulfate, but it's hydrated, .5H2O. And I'm going to heat it, and what it should do is we should see here some water vapor, and this copper sulfate should go from blue to white, showing it is changing. There's our first reaction. Let's have a go and see if we can do this. I'm going to take my copper sulfate and I'm going to put it into simply a boiling tube. So there's my boiling tube. Let's put in some copper sulfate. There we are. I don't really want to put anything that's too lumpy in there, and there is a massive great big lump in there, so I'm just going to oink that out, technical phrase. And we've got really some quite nice blue crystals in there, and I've got a few crystals that I made another day. Let me just bring it a bit closer. And these are crystals of copper sulfate. They look quite sort of pretty. But I'm not using those because trying to break those up is really quite difficult. So I'm just going to use some powder that I've got. So let's put that chemical away. I'm going to hold this in my clamp. And let's light the Bunsen burner. Let's heat this copper sulfate. I only want to warm it gently. I don't want to heat it too much, too vigorously. And the reason I don't want to do too much to it is simply that I don't want it to turn to something like copper oxide. Immediately we can see though I've got some water here being formed, and it's turning a sort of a whitish colour. So let's carry on. You might see at this end we're getting some water formed. You might be able to hear the water boil. It's changing colour, and we've got some water, definite water vapour up the top here. I can get rid of that simply by heating and encouraging the copper sulfate to go. Now what I can do to try and make this reaction better is just to give it a little bit of a stir down the bottom. I'm losing some of my product here. So I'm heating it quite gently because I'm trying to drive off all the water. What I'm getting, unfortunately, usually the case, is some of this stuff sort of sticking to the test tube. So I'm just trying to encourage some of it not to. Yeah, that didn't do my boiling tube an awful lot of good. Won't stop the experiment, however. I'm deliberately actually using an old boiling tube for this experiment. But now we are getting virtually here a whitish powder, sort of a definitely a grey sort of colour. Just trying to break up the lump. It's always a problem with this, that it tends to form a big lump. So let's carry on heating. I'm basically just trying to drive off all the water. Try and hold it that way so you can see better. You can see down the bottom here we have quite a whitish powder. What I'm trying to do is make sure I haven't got any bits left, any bits of sort of blue left here. And I certainly can't see any, and I'm not seeing any more blue in there. So what I'm going to do is I'm just going to put that down, and I'm just going to put it into a mortar and pestle. I don't need the Bunsen burner anymore, so I'm going to turn that off. And if we put this in here, and that boiling tube is certainly no good anymore. What we've got in here is a whitish powder. And there doesn't seem to be any more blue in here, because we've turned all the copper sulfate, which is hydrated, into this white powder, anhydrous copper sulfate. And there we are, you can see the white powder, anhydrous copper sulfate. And this isn't hot. This now has cooled down and I'm quite happy touching this test tube. It's not hot. Now, what happens to this if we add a small amount of water to it? So let's try now taking my second experiment, and I'm going to add a couple of drops of water. Let's see what happens. And you see that? Immediately that has gone blue. We've got here blue crystals. If I can get the angle right. Down there. Blue crystals. Trying to hold it so we can focus easily on it. Do you want me to come back a bit? We've got some blue of copper sulfate. I'm going to tip this out so we can have a clearer look at it. I'm going to put it on the lid of the copper sulfate, won't make any difference. Yeah, well, I expected that to happen. In other words, it didn't really want to come out. We'll get a small spatula. And there is my blue of my blue copper sulfate that we started the experiment with. If I give it a tiny little bit of water here, a bit more than it needs, you can see the blue colour. Trouble is, if I put too much here, as I've done now, it's starting to dissolve. But what I do notice with this is, and I didn't try it because there was little point in you trying to believe me, but that here is now quite hot. That has given out heat, and I can feel the heat, even though really I can only tell you about it. So we've got our copper sulfate turned into a white powder. So we've got our original. Lid's not going to come off just because I want it to. So we've got our original copper sulfate turning into anhydrous copper sulfate, and then we can reverse the reaction and we can make it go back that way, forming again these sort of little crystals here. If I add a little bit of water to that, you can see it makes the same sort of blue mess that we've got on the other one. Just trying to show you it makes the same sort of colour. These have made better crystals. And if I want to make better crystals out of this, then it's usually a good idea to try and dissolve this. And once I've dissolved it, you can see the colour is becoming the same. Once I've dissolved this, then I can recrystallize it back, and it makes a sort of a better shape and colour. So there's our copper sulfate making anhydrous, and then from the anhydrous making hydrated copper sulfate. If you leave the copper sulfate, you can see that there is a slight change of colour. Can you see this is sort of grey, and that is sort of a whiter colour. And if we leave that, that tends to go greyer, and that is this absorbing water. This anhydrous copper sulfate will absorb water, and it will gradually go a bluer colour, and it will do it quite naturally by taking the water out of the atmosphere. So we've looked at here another experiment. So we took the copper sulfate with 5 waters, we drove the water off, and then this gave us at the bottom anhydrous copper sulfate. And then if we add water to that, then we end up with what we started with. So if I write the equation in full for you, we've got copper sulfate with 5 molecules of water attached to it. We heat it and it forms copper sulfate plus water, and if we take the water to anhydrous copper sulfate, we form hydrated copper sulfate all over again. There are many of these experiments that we can actually do. Another one that is quite common is the test for water. The test for water is to use cobalt chloride paper. So we take some cobalt chloride and we put this onto some paper and we dry it. And what happens is basically this is a sort of a pinkish solution, and it turns blue when it's dry. What's happening is I've got cobalt chloride with some water added to it, and when I dry it out we end up with some cobalt chloride without any water. And only when you add water to this does this turn from blue to pink. We could use copper sulfate for our test, but it's a little bit harder to do that. We can't really get anhydrous copper sulfate paper. It's really difficult to do. So we could just take a small amount of anhydrous copper sulfate and if it turns blue, then that could be a test for water. The problem is that in fact it will go blue when you add a few other substances to it, whereas cobalt chloride doesn't, and that's why we use cobalt chloride paper to test for water. When we go one way with our reaction, our copper sulfate dot 5H2O, we add heat, so this is endothermic, and when we come back, when we take our copper sulfate plus water, so we've got an endothermic reaction and an exothermic reaction. It's endothermic when we go one way, and it's exothermic when we go the other way. And this energy in these reversible reactions is quite interesting. Sometimes we can get a different type of reaction where it's going to go both ways at the same time, and that is what we'll have a look next time on GCSE Chemistry, going through topic by topic. If you like this, subscribe, give us a thumbs up, and I'll see you next week. Stay safe. Bye bye.